All right, so we'll do 6-1 and 6-8 today. 6-1's really short. Wednesday, we'll do 5.4, and that'll be the last section for test 2. So next week, I'll review and open up test 2. Okay? So I'll probably send out a bonus this week for test 2. So this one's pretty short, and it deals with radical expressions. So basically, you'll have one problem where we find the domain. The other 5 problems, you're just going to pick which graph it looks like. So they'll give you 4 graphs, and you'll graph the function and pick one of the 4 graphs. Okay? So the main thing is that's the second thing we was worried about on domains was the radicals. First thing was the fractions. I'll test you on that first test on, okay? So this will be the finding the domain of a radical. Get right up marker. So when we look at domains, what we're worried about on the domain of a radical is we cannot take square roots of negative numbers. If you try to take square roots of negative numbers, you get the imaginary numbers. So under that radical, we got to keep that 0 or greater. Okay? So now radicals will be this kind of f of x equals something like a square root of x. Okay? So the first thing I do is whatever's under that radical, I want to set it greater than or equal to 0. So set that x greater than or equal to 0. Now you might have an x plus 2 under there, or 3x minus 5, or something, okay? So you're going to set it greater than or equal to 0. We then would solve for the variable, or solve for the x. When I do that part, I'll end up with something like x is greater than or equal to 2. X is greater than or equal to negative 2. Something like that, okay? I'm then going to write my answers in set builder notation. So write in set builder notation. And y'all, set builder notation was when I had the fancy curvy little parentheses, and we said the variable was x. That vertical line means such that x is real number, and x is greater than or equal to whatever number we get, okay? Now, depending on when you're solving this, if you divide by negatives, remember, you got to reverse the direction of inequality. So you could have a less than or equal sitting there, okay? Depending on if I had to flip it or not. And that's really it on finding the domain on these, okay? So I'm going to do 2 examples. One where my x is positive, and then I'll do one where you get a negative x and you actually got to flip it, okay? So in this one, we're just going to determine the domain. So mine has f of x equals square root 4x minus 7. So my domain has to include all the numbers that I can put into that X and keep that positive or at least a 0, okay? So the first thing it says is take what's under the radical, set it greater than or equal to 0. So I'm going to set 4x minus 7 greater than or equal to my 0. Then I'm going to solve that for that x. So let's see, to solve this one, I'm going to add 7. So that 4x is greater than or equal to 7. And then I'm going to divide by 4. Now this is a step that if that was a negative 4x, that's when I would start reversing my inequality, okay? But we're all positive here, so we'll divide by our positive 4. So mine's telling me x has to be greater than or equal to a 7 over 4. So basically, all you're doing is putting this into which choice you pick. They'll have one of these with a greater than or equal, a not equal, a less than or equal. And then I think that the last one says this can be any real number. Okay. So on mine, we would have x such that x is real. Oh, they didn't even put that x is real part, so we don't even have to put that, I guess. So they're not even putting that on these. So mine would just be x such that x is greater than or equal to 7/4, okay? So not bad, was it? You ain't got to graph it, so all you really got to do is solve it and get me that answer, okay? Now I'm going to do it like a 1b. And this one will be square root of 7 minus x. Because some of y'all might get math lab questions that make your x's negative, okay? But y'all same thing, right? I'm going to take that 7 minus x, set it greater than or equal to 0. So I'm going to solve that. I'm going to subtract my 7. So I now have a negative x is greater than or equal to negative 7. But we want the x positive, so now I will divide both sides by negative 1. And since I'm dividing by negative 1, we're going to change it around, okay? So this will now be a less than or equal. And it looks like x is going to be less than or equal to a positive 7. That makes sense. If I put a 7 in there, that's going to give me a 0. If I put an 8 in there, 7 minus 8 gives me a negative 1, which makes it imaginary. So I can't go bigger than 7. Now, all these negative numbers will work because 7 minus negative 8 is like a 7 plus 8. So all my negative numbers will basically turn positive, but because of that subtraction. So here we go. All we're doing now is just putting it into our parentheses. X such that x is less than or equal to 7. So they'll give you 3 options on the less than and equal, greater than or equal, or it'll have a not equal there. The only time we use a not equals was when it was fractions. So fractions use the not equals. Radicals, you use the less than and greater than stuff, okay? But then they just wanted y'all to graph some of these on those calculators to see what kind of graphs you're going to get out of these, okay? So my next one, I'll graph. Oh, let me try one here. I'm going to graph f of x equals square root x minus 2. Now, we do know the basic graphs on these. So this would be the basic graph. The basic graphs of the square roots basically was a slow growing curve to the right, okay? Yours kick that out on there?
I'm not sure.
Yeah. Now yours has already done the move on it. So since this is the basic graph, remember from 7-2, when I attack them x's, they move me left or right, right? And remember, they're sort of opposite what you think. Although they subtracted 2 on this one, when you subtract 2 from the x's, it actually moved it to the right. So our picture of this one, when we're done, it should have moved it over 2 units to the right, and then made that little slopey hill, okay? But y'all, these we can just go to y equals and graph them really quick. You get yours? No. Let me see. So go here, y equals. Clear that one. To get the radical, you see that blue radical there? You hit the blue button and the x squared button, gets that radical, and then put in your x minus 2. Are you doing hard? Watch it. See that button right there? Oh, x. Whoops. So I use that for my x and then minus my 2. So you got the graph, now hit graph. You can see how it sort of kicked it over a little bit to the right on that, okay? Now let's try one more. How about, oh, let's see what I want. This one has 2 square root of x. Now, we'll say this. They didn't give us this move in 7.2 when we were doing the moves. But when you put a number in front of these radicals, what it's doing is it's like stretching that graph. So these numbers stretch the graph. So what this will do is it's going to take all the answers and multiply by 2. So if you had a 1 for the square root of 1, multiply by 2, it's going to turn that 1 into a 2. Square root of 4 used to be 2, but since I got a 2 in the front, it would make that value 4. Okay? So it's going to multiply everybody by 2, so it's like doubling the size of this graph. So what it would look like, if you was to graph this, so if I put a 0 in there, square root of 0 is 0, 0 times 2 is still going to be 0. So it's still going to sit around here at 0. Let's put a 1 in there. Square root of 1 is 1. So 1 times 2. So at 1, I would be at 2. So it's already, because this was 0, 0, 1, 1. So it's already stretching me a little bit. Over here at 4, square root of 4 is 2. But that 2 times 2 would give me a 4. So see, all my values before were going to come down here. So you see the difference? Instead of going down here, it's now coming up here. So you just want one that looks like it stretched it a little bit. Now they'll give you one picture right, and then the other ones will have them graphs going every other direction there is, okay? So not bad on those, just graph them and see which one of them pictures you're coming up with, okay? Main thing on that is finding them domains. Which I'll probably give you 5 domains in just one of the graphs. Leave it off to what I've done on there. So let's get into 6-8. And 6.8 has more work in it, so. So 6.8 will officially introduce you to the increasing and the decreasing. So I think on was it 7.5, one of the equations had increasing and decreasing on it, and we really hadn't learned those yet. So officially, this will be where you, because notice our book is out of order, right? From what we're doing. So, all right, so we'll officially learn increasing, decreasing, and piecewise functions. So I'm going to start out with the piecewise functions. Then we'll get into the increasing and decreasing. And we'll just look at piecewise functions to figure out which equations we use. At the end of this section, they evaluate them. So have y'all ever used the piecewise function? So say yes. Do you work? Do you work?
Yeah.
You work? Well,
yeah.
If you work, you're using the piecewise function to figure out your pay usually. Is it true if you work 40 hours, you go by, make $10 an hour? For 40 hours, I would use an equation that took my hours times my pay. So if I make $10 an hour, work 35 hours, I can most times get that $3.50.
I get 15.
So up to 40 hours, you can do that. But if you work 41 hours or 42 hours, don't you got to use a formula that accounts for you making overtime pay, which is usually time and a half or something? So any hours over 40, we're going to hit with a time and a half. That's a piecewise function. I use two different equations for the same answer depending on what value are my x's. Okay, that makes sense? So if I work 0 to 40 hours, I use one equation. Anything over 40, I'm going to use the overtime equation. That's all the piecewise function is, okay? So basically, to me, it's a set of equations that depends on the value of the x to determine which equation to use. And once I figure out which equation I can use, then I put my x value into it, evaluate it, get me an answer, okay? So this first example is just going to get you used to picking out the equation you would use. Later on, we'll evaluate them at the end, okay? So given f of x equals, and on this one, y'all, I'm going to have three equations. You use the equation x squared for any x that's less than -5. Not equal to -5, less than -5. Which would be like a -6, -7, -8. Any of them numbers, I'll plug into the x squared equation, okay? It'll equal 3 times x for -5 less than or equal to x less than 3. So if it equals -5, or is any number less than 3, I would use the second equation. My third equation is x minus 4 for any x that is greater than or equal to 3. So I've got all the numbers possible in my domain, right? Anything less than 5 is headed towards negative infinity. In between -5 and 3, I'm covered. Anything bigger than that 3 towards positive infinity, I'm covered. So no matter what x y'all get, you have to find one of these 3 equations. So y'all have a question on this one. Which equation would we use to find f of a -6? So you got to figure out, is -6 less than -5? Is it in between that -5 and 3? Is it bigger than a 3? So which equation y'all using? X squared, 3x, or the x minus 4? The x squared. Because that is less than -5, okay? So what I'll do is just take that -6, plug it into that x, and see what I want. But they didn't ask us to do that, they just want to know which equation you would use at this point, okay? All right, so let me draw another one of these. Let's see. I don't like this. So they're giving us f of x. It's going to equal x squared for any x less than -2. It's going to equal x minus 4 for -2 less than or equal to my x less than 1, and then it's going to equal 8x for any x greater than or equal to +1. So this one wants to know what equation would we use to find f of 1. So do I want to use the x squared equation, the x minus 4 equation, or the 8x equation if my value was a 1 for my x?
8x.
8x, right?
Yeah.
Because you see a 1 there, but it's got to be less than 1 for this one. To equal 1, that's what the equal is here. This one says it can equal 1 or be any number bigger. So it is definitely the 8x, okay? So pretty good in that. All right, so now let's get into the intervals. We're going to look at increasing, decreasing, and constant intervals. Now, here's the thing where I get people. Although I'm looking at the graph rising to be increasing, I don't care about the y values. I only want the x intervals where it's increasing. So we only want the x values when describing the intervals. Okay? Although my y's are going from 0 to 1 to 2, I don't care. What x values are they going up? What x values are they coming down? What x values are they straight across? Because that's what these mean, right? Increasing. Now, here's the thing you got to remember on the graph. On the graph, we read the graph from the left to the right. So if it's going uphill left to right, it's increasing. It's not decreasing because you can't read it right to left. You got to go left to right. So increasing is going to go uphill. Left to right. Which means if you were looking at the slope, it has to be a positive slope to go uphill. Decreasing is going to go downhill left to right. And then have you ever heard a word called constant? Sort of means what? It remains the same, okay? Which means on a constant, it'll be a horizontal line left to right. So I'm going to draw one of these, trying to draw it. And we'll find our intervals of increasing, decreasing, and constant. So we'll just take the intervals of our increasing, decreasing, or constant. All right, fun part's going to be drawing these. All right, so I'll go out 1, 2, 3, 4, 5. All righty. Over here at 3, -1, I got a crossover point. At -3, -1, I got the crossover point. So this graph goes straight across from that -3 to 3. And then right here, it goes uphill, and right here comes in from the downhill, right? So I've got a decreasing, a constant, and an increasing section on this, okay? So the first thing they want to know is my increasing. Now, you never use brackets on these intervals. They always got to be curvy parentheses. So those points can't be both. So we say it's increasing right up to the point, and then it starts doing whatever after, okay? So increasing is my last section of my graph where it's going uphill. So my question is, what X value does it start increasing at?
+3.
+3. So just go to that x-axis and see what that thing is, right? And then it's increasing towards infinity. Go with me. From the X value of 3, my graph is going uphill. So let's look at the decreasing. Well, this is first section where my graph is going downhill. The question is, where does that graph start at?
I just want to get some track.
Negative infinity, because I'm way out here, right? On my axis, so I'm at negative infinity. Until I hit what X value? -3. So I'll just go up to that line and say, oh, you're at -3. So the last one, constant. Where do I start being constant at?
-3.
-3. And I put being constant at +3. So look at these intervals. You go from negative infinity to -3 downhill. From -3 to +3, I'm constant. And then from +3 to infinity, I'm uphill. So this answer has to include it all, right? let me try to draw this next one. This is the harder of the two. Well, okay, let me try to draw this. Yeah, I'll depends on this one, okay? All right. At -1, 2. So at -1, 2, we're going to put a point right there. And then from that point to the right is a straight line. So from here over, it's just a straight line like that. Make y'all's a little straighter than mine. It ain't going uphill, it's a straight line, okay? Now, at -3, -3 here, and I'll write these points. This was what, -1, 2 here. This point is -3, -3. So from there, this point goes straight down to it. This point is -5, -3, and at that point, it's straight across. All right, so let me think. This point here is at -7 and 3. So let's see, -7, 3 is right up here. But from here, it just curves from it. And then on this side, it just curves and makes a line. So don't worry about where the curve is crossing the x-axis. Just get the main points I got on this. So you're -7, 3, -5, -3, -3, -3, -1, 2, and then that thing is going straight across. Little straighter. And guess what? It wants the same things, the increasing, decreasing, and constant. I will say this, increasing, I got two places this is increasing. Although they got this arrow going to the left, it don't matter, we're still going to read it left and right. So this section right here is increasing, and this section right here is increasing. So let me get the first one. This first section starts at negative infinity, and it's increasing until you hit the x value of -7. Okay, good job. Now, this part we said was increasing. So since I got two parts, I'm going to use my union, because union means and. So I got this interval and the next interval. So that little bitty second section, where did it start increasing at again? -3 on my x's again. And then increases till you hit what x value? -1. All right, so that takes care of my increasing. Next, I'll look at decreasing, and y'all really only got one part where it's decreasing, and that's right here, that other side of that little parabola looking part. So at what x value do I start decreasing? And I'm decreasing until I hit Okay, so that just took care of this section. So it was a short section actually from that -7 to -5. It had that sharp drop. Now I want constant. I got two intervals where this is constant. So how about this first interval? From what to what? Right, because at the x value -5, it starts being constant till it hits the x value -3. Then I'm going to use my union. So then the second part starts being constant at what value? -1. And I'm constant until I hit infinity. So remember, your interval has to go through everything. So -infinity to -7, -7 to -5, -5 to -3, -3 to -1, and then finally -1 to infinity. There's no missing numbers in there. It starts at -infinity and cruises all the way through the positive infinity, okay? So that's a little bit of work you'll be doing. Then we're going to teach you words like relative max and relative minimum. So when they talk about a relative max and relative minimum, they're not talking about the overall graph maximum and minimums. But you see this little section right here where I got the little U? This point right here would be considered a relative maximum because it's the maximum of this section. So they're only looking at sections of the graph. What's the minimum or the maximum of that section? Okay?
So like y is highest one, or like,
Say again?
so y is highest one, like y? What do you mean y or x? Sorry.
Well, I'm just looking at this value, and the maximum would be the 3, and it happened that the x equals -7.
Okay, so we're looking for y. Right?
Okay?
So we're looking for y. We're looking for y.
You're looking at the y values for those min and maximum values, and then we'll say where do they happen at, what x value. Okay? So a relative maximum basically is a section of the graph with a peak. Right? Maximums look like peaks, and minimums will look like I call them valleys usually. So that'd be a section of the graph with a valley. Okay, so I'm just looking at little sections. Do you have a max or a min in that section, next section, and same thing, okay? So let me do one of them. This will be another fun graph. Probably not as bad as that one, but we'll see. So I'm going to identify any relative maximum or minimums. Minima. And the intervals of increasing and decreasing. Okay, so they want me to find any relative min and maxes and then go through and identify where am I increasing and decreasing at. All right, so let's try to draw this one. So here we go. right, so I'm not going out real big this time. How about 5? All righty, over here at -3, I've got a point. So that'll be -3, 0. Then over here at -1, -2, I got my second point. So to the left of the first point, it just goes downhill. This comes around and hits this point. So let me make that a little better because it sort of comes down and then wants to U again. And then from this point, it heads off towards that way. So I've only got 2 things that I'm really worried about. This right here would be a maxima. This one right here would be my minimum. Now we're not worried about these ultimate maximums or these ultimate minimums. We're just looking at these little neighborhoods here, okay? So maxima and minimum. So for the maximum, it'll say the relative maximum is blank at x equals blank. And then it'll say the relative minimum is blank at x equals blank. So I've got a maximum sitting right here. What is the maximum value? So that would be 0 at x equals -3. I've got a relative minimum of blank at x equals blank. So what's my relative minimum? -2 at x equals -1. So we're just going for the x and y values off these 2 points, basically. So here's the question. I need to find the increasing and decreasing. So let me start with my increasing. I know that's going to be in parentheses. I got 2 places where I'm increasing left and right. The first section up until that max, and then this last section from that minimum. I'm going to catch this first section first. It starts increasing out here at negative infinity. It's cruising along these x-axes and increasing until I hit that x value of -3. Then you're going to union that because you got another part where it's increasing. It's increasing on this last section of my graph, starting with this x value. And that x value is -1. And as you cruise out these x's towards infinity, it's still increasing. So y'all, 2 ways you can get the decreasing one. You can come in here and look at your graph physically, or you can realize it's got to be the 2 points in between. Because I've got my negative infinity stuff, I've got my positive infinity stuff. So the only x values I'm missing on my intervals would be from first x value, -3. And it stops at the second x value of -1. So see, that's what I'm saying. You could almost look here and say, hey, I'm missing the part in between the -3 and the -1, right? All right, so y'all good on that? They're a little tricky, but once you get into realizing that on these intervals, I only want X values, you'll be a lot better in life, okay? And if you don't have to try to draw these graphs, they'll have your pictures already drawn. Okay? All right, so remember when I started, I said at the end, we'll find those values for the piecewise functions. So here we go. Given f of x equals, I've only got two equations. It's going to equal x plus 8 for x less than or equal to 1. It's going to equal 7 minus x for any x greater than 1. They want us to find f of -3, f of 1, and f of a +5. So y'all, there's three problems in this basically. They want me to find that f of -3 first, then come back and find the f of 1, and then come back and find me an f of 5. So I'm going to start with f of -3. For me to start this off, I need to know which equation I'm going to use for that -3. Am I going to use the top equation or the bottom equation? Bottom? Oh, no, you're only going to give me two different things. So let's ask this. I'm finding -3, right? Is -3 less than 1 or greater than 1?
Oh, sorry.
So it's going to be less, so we got to go with, we're going to use the top equation, x plus 8. But in place of that x, I'm going to put what? -3. So this basically becomes a -3 plus 8. All right, so -3 plus 8 is? Which means f of -3 is 5. Okay? All right, what was next? F of 1. Do I want to use the top equation, x plus 8, or do I want to use the bottom equation, 7 minus x? Want me to let Martin redeem himself?
No.
All right, so here's my question. We're finding f of 1, right? Is 1 equal to or less than 1?
Yeah.
Yep, so we're going to use x plus 8. In place of that x, you're going to put a 1, so you're going to do 1 plus 8. So these are my numbers I'm putting in. But notice they use the same equation because both of them was equal to or less than 1, right? So let's see, 1 plus 8, we get a 9. So f1 is 9. All right, so now I'm going to find f of 5. So 5, is it less than or equal to 1, or is it greater than 1?
It's great.
Greater than 1, so I'm going to use that equation that says 7 minus x, but my x is 5. So that f of 5 equals 2. Good job. Okay, so these were the numbers I was putting in. I want y'all to see it's the same as these, -3, 1, and 5. But my equation depended on those values to get those numbers, okay? These aren't too bad if you get used to the, which one do I use, okay? I got one more and then I'm gonna quit for today. What did it say, 5-4 for its own little special day, okay? All right, this has 3 on it. H of x. All right, so it's got 3, so let's see. It's going to equal -4x minus 11 for any x less than -3. it's going to equal 2 for -3 less than or equal to my x less than 2, and then it's going to equal x plus 5 for any x greater than or equal to a 2. Now, do y'all know what it means for this second equation when it's just got a 2 here? Notice there's no variables with it, right? So what that means, if your x is equal to -3, but less than 2, your answer is going to be 2 no matter what. It's like a constant function. You don't have to worry about the x's. It's 15 between those x values. It's going to equal 2, almost like if you was on a salary pay. Y'all heard of that? Don't matter the hours, you still get the same pay or whatever. Let's see what I'm going to find. We're going to find h of -5, h -1, h of 2, and h of a 6. So they want us to go through about 4 of these. So y'all, let's start with h of -5. I got 3 equations. So I want the top one, the middle one, or the bottom one. So what you got to ask yourself is -5 less than -3?
Yeah.
Definitely. So we're going to use the top equation. So this will be -4 times x, which is -5 minus 11. So y'all, what y'all get when y'all do that -4 times that -5? We got, I heard 2 different numbers.
I know.
Well, you multiply those up.
Did I do it? I got a 9, I'm sorry.
Oh, you must have added those.
Oh, yeah, must be.
I think you added them, right?
Yeah.
So this is 20 minus 11, which will equal, oh, you finished it all is what he did. Okay.
Oh, I'm sorry, that's me.
Okay, he was throwing me a curveball. I thought he was adding that -4, -5, making that 9. Okay, you good.
Just hold on, calculator.
Yeah, you just knocked it all out at once. Okay. So h of -5 is definitely 9.
That's what you meant.
How about h of -1? When I use the top equation, the middle equation, or the bottom equation? So -1 less than -3 is -1 in between the -3 and the 2. So it definitely is. So we're going to use the second equation. So that means h of -1 equals 2. And that's what I like about that one. There's no work. You ain't got to put in the extra nothing because it's just 2 no matter what on those numbers, okay? What was next? H of 2. So h is 2. Am I going to use the same equation? Oh, no, I'm going to use the bottom equation. Because it said if it equals 2, you got to use the bottom equation, which is x plus 5. So that'll be 2 plus 5, which will give me 7. So what's left? H of 6. So am I going to use the top equation, middle equation, or the bottom equation? Bottom one, because see, this one says, hey, anything greater than or equal to the 2, we're going to use the bottom one. So that'll be x plus 5, which will be 6 plus 5, and I get 11. Okay.
Can you tell I'm very sleepy?
Huh?
Can you tell I'm very sleepy? Can you tell I'm very sleepy? I'm not really thinking clearly.
Oh, okay.
Yes, every time you say something like earlier, I wasn't thinking, and then earlier again, yeah. I'm very sleepy. I'm
Okay,
sorry.
so you with me on this though?
Yeah, I'm good.
Okay.
I understand, but it's
Okay.
like when I say the blur out the wrong answer, I'm not really thinking.
Well, you didn't get the wrong answer. You just told me the final answer.
Yeah, but then
So you was thinking faster than that.
I was thinking like -3.
What?
I wasn't thinking about that.
Yeah. Okay. So he's like a little ahead of me on that one. You know, like how the hell is he getting a 9 out of that -4 and that -5? But he didn't went through the whole problem. All right, so questions on this. The trick, y'all, just watch out on those intervals. You got to use the X values. Okay. Anytime they ask me range is when I use my Y values. Okay. And just be careful when you're picking which equation you use. Find where those X's are fitting in there, grab that equation, put the X in and go. Next class, we do what we call the difference quotient. Y'all ever mess with that? Y'all have never seen nothing like this? F of X plus H minus F of X. Y'all ever seen that? You will. On Wednesday. I will say that we keeping y'all that formula right there for those of y'all going into calculus. Like Roscoe and who else going into calculus? Some of y'all good at math. It's a fancy way. Now y'all use this formula, but y'all just don't realize it. Have y'all ever used this formula?
Yes.
Some formula, y'all used it. That's basically what this is. Y2 would be the X plus H. F of X would be the Y1. So it's the Y value, the second Y value minus the first. This H is basically the difference between the 2 points. Instead of doing X2 minus X1, we just find what the distance is and use that as our H. We won't be finding slope much. We'll just be working this formula. So I will warn you, anybody weak at foiling, y'all can foil good. If you can't, figure Wednesday because we're going to foil crazy. I'll foil 2 of them, and I'll take that answer and I'll probably foil it by another one.
Well, I was just doing some of that, and it was so confusing. Just like the formula is just kind of confusing to me.
So that F plus H stuff. So what this means is, let me just show you an example. So I'll do an easy one. I'll do just a straight line. So y'all are familiar with, well, now I'm going to call this, I'm just going to make it an F of X. So saying F of X equals 2X plus 3. Now, y'all used to remember the y was mx plus b, the m was going to be my slope stuff. Well, we're going to use that formula to find it. So to use that formula, first, I find f of x plus h. To find f of x plus h, well, this has an x, I'm going to put x plus h. So that'll be what? 2 times x plus h plus 3. Okay? There's only one more thing you can do to that, and that's distribute that 2 through the parentheses, right? So I'm going to distribute, so I get 2x plus 2h plus 3. That is now the f of x plus h, right? So I'm going to plug it into that formula. F of x plus h minus f of x all over h. You know f of x plus h now, right? Is this. Minus f of x, well, they gave me that. It's this, right? 2x plus 3.
Okay.
All over h. If you do this correctly, everything up here that does not have an h in it is going to cancel out.
Oh.
Watch this. I'm going to rewrite this. 2x plus 2h plus 3. Distribute the negative and make that a negative 2x. Distribute the negative and make that a negative 3 all over h. If you did this correctly at this point, everything that does not have an h on top is going to cancel.
And you'll have the
That
2x.
cancels with a negative 2x, right?
Mm-hmm.
This 3 cancels with a negative 3. So I end up with a 2h over h. Can you simplify that any further? Yeah, I can cancel those
2.
out. So that this gives me a final answer of 2.
Yeah.
Then 2 the slope of that line. That's my M. So straight lines, you can pretty much figure out the answers because it's going to equal the slope. So what about a curvy line?
That's where I started.
Those are a different story. So that's where I'll start pulling them. If I get like an X and I put an X plus H in for that X squared, I'm going to have to pull that X plus H. Some of these I got a cube on, so that's what will be happening on Wednesday. We'll be doing that one problem or one formula with 5 different problems. So the cubes are tricky. And then there's some that look like a 2x squared plus 3x or something like that. They're sort of tricky. But because everywhere there's an x, I gotta put the x plus h stuff. Okay, so I'll show you all my tricks on that. Like I said, on that one step, if it don't have an h, it's gone. So if you ended up with something that didn't have an h, you did something wrong up here, okay? And then you'll notice they all have an h at the end because they all got to divide by that h eventually. So what would this turn into? What if you had this, an h to the third, and you divided it by h? What would that turn into? H squared. So watch what we're doing. Treat that like it's got a 1 on it.
Oh.
So that you know it's going to be an h, and then you subtract 3 minus 1 would give you 2. So when you multiply, you add the exponents. When you divide, you just subtract them. Okay? Because you're going to have some crazy stuff on some of these going along that top. And they're going to be really long, but all of it's going to cancel out but the h's. Okay? So the worst things you'll have, you might have stuff like 2h squared x plus something like 3h, something like that, all over the h. You got to go through and cancel one of these h's out of everybody. So don't stress on those yet. I'm giving you nightmares now, right? Hopefully coming up Wednesday. That's the last thing on this section for the test. So test will be a little tricky because you got a lot of different graphing things on it. So
Yeah.
that's 7-2, moving the graphs around and stuff. So how many of y'all did my study guide before y'all did my test 1? So that help y'all? No, you didn't want to do it too much though, so I'm gonna make him do it next time. Give him a good grade, then I'm gonna make him do it again. I might even make him do it again over there.
Oh, wow.
That's why for this test, is just practice and practice and practice in study guides. Okay?
Yeah, I just saw my mistakes and remembered them.
Huh?
I just saw my mistakes and remembered that they were supposed to
And
be.
then think will be done. But then, now if I catch stuff like, instead of putting x equals -3, y'all just put the -3. If I catch them, I'll change them and give you points. Because mathematics is a little picky at times.
So you can go in and change it?
Huh?
You can go in and change it?
Oh yeah, like if y'all got some and say you think you got them right, but it was grading you wrong, let me know those numbers. I can go in there and if they're right, I can override.
Oh, okay.
That's how I do y'all's bonuses. I override it and add 5 points to your scores and stuff.
Okay.
So
We had a lot of stuff due yesterday at midnight.
yeah, but it's on homework, and what it is, I clicked everything to let you work past my due dates. So even if something says due, it's going to let you work past the due dates. The only thing that won't let y'all work past my due dates is my test.
Okay.
So y'all would have to send me a sob story about why you couldn't do my test on time, and then I could add time to it or whatever.
Okay.
And if y'all needed that, okay.
Yes, sir.
Most of y'all that are online with me don't do too bad. I got some people I don't even know who they look like out there somewhere. I think when did the other day me and you was the only ones here? Oh, they come in a little late. That's right. That's on Wednesdays. Y'all usually just me and Roscoe on Wednesdays. No one else wants that, huh? All right, so hold on. Let me grab these men on the line real quick. Oh, yeah, you are good. Alrighty, y'all, I'm gonna save our video and I'll send this out to y'all in a little bit.
Yes, sir.